here is where we were at. We are going to refer to, if you don't have it out or didn't hear me say get it out, we're going to refer to that unit circle there. And I know mine just got squished super small there. Sorry about that. So we are on the quadrant angle pi. Okay, so the first thing I got to do is I got to find that pi, which is right here. Okay, so can you tell me in the chat, help me out, is the sine the x coordinate or the y coordinate? Tell me in the chat, is the sine the x coordinate or the y coordinate? Okay, good job. We've got a lot of y coordinates. So all I'm going to do is I'm going to look for my y coordinate, which just happens to be 0. That's it. It's 0. Done. It was really funny because when I was looking at how many minutes these problems took, like because the assignment will tell me how many minutes, it says like people were taking 5 minutes to do this problem. It should take us 30 seconds, right? So it should, when I assign a longer assignment, it means hopefully the problems are easier, okay? All right. Cotangent of 3 pi over 2. I noticed 3 pi over 2 is down here. All right. In sine cosine world, okay, what is the cotangent? Cotangent is what divided by what? And I want it in terms of sine and cosine, not opposite adjacent hypotenuse. So in sine and cosine world, cotangent is what divided by what? You might have to scroll up in your notes. Remember, it's the reciprocal of tangent, so that might help. Tell me in the chat, what do you remember? Okay, so I don't want adjacent and opposite. I want it in terms of sine and cosine. So remember that we know that the tangent is the sine divided by the cosine. So what does that make cotangent? There we go. We don't see cotangent as often, right? We know tangent because it's got to be sine divided by cosine. All right. Good morning, Samantha. So I'm going to take my sine. Remember, you told me is the y coordinate. So I'm going to take -1 and I'm going to divide it by 0. Ooh, what's wrong? What do I have to write really fast so my paper doesn't explode? I can't divide by 0. What do I have to write to replace that? Quick, put it in the chat. All right, good job. I got it right undefined. I don't want my computer to explode, right? Because I'm dividing by 0 in there. Woo, that was a close one. All right. Looking at the secant of pi over 2. So pi over 2 is up here. Secant, what's secant the reciprocal of? So what's secant the reciprocal of? Can you tell me that in the chat? What's secant the reciprocal of? What is that? Good. That's so much better than yesterday. I know we were struggling with those ones yesterday, the ones that we were good at saying cosine's reciprocal is secant, right? But we were kind of struggling going backwards. So really good job, guys. All right, so I'm going to take my x value, which is right now 0 over 1, and I'm going to flip it, and uh-oh, I don't want my computer or my paper to explode again. I had better write undefined again. Okay? All right, easy peasy lemon squeezy, right? Let's look at this next piece. So I don't tend to work with this as much, right? When we're doing these, I try to, hey, it's a reference triangle, but this is the concept behind what we've been doing with all those reference triangles, okay? So basically what this is saying, actually there's a little bit of a word we got to fill in, right? Let theta be an angle in standard position. Its reference angle, sorry, that's a little bit small to fit in there. So its reference angle is the acute angle. And remember we said it's got this funny notation. It's got like a theta with a prime on it. And I know you saw that when you were doing like the images, when you were trying to do transformations in geometry, they use that as the pre-image or something. I don't know, it's been a long time since I taught geometry. Formed by the terminal side of theta and the horizontal axis. Okay, so basically what they're saying is when you have the terminal side, the distance between that terminal side and the horizontal axis becomes the reference angle, which means our reference angle could land in a lot of weird places, okay? So in this one, it's the terminal side, so it's the distance in between here. And in this one, here's the terminal side. It's the distance in between here. Unfortunately, how we would calculate that reference angle kind of changes depending upon where we're at. So you got to, I just kind of use logic with this one, okay? So if I am in this one here, I know that on a straight line, it equals 180 degrees or pi, okay, in my radian world. So I know I've got to take my original angle and I've got to do pi or 180 minus that original angle to calculate the official reference angle, okay? All right. In this one here, it's weird because my angle is bigger than 180. So I'm going to kind of go the opposite direction. I want to take that 180 out. I'm going to subtract this out. Subtract the 180 out, okay? Or the pi out. So I'm going to use the angle minus pi or 180. And again, you kind of got to draw the picture and know where you're kind of at, okay? And then this one here, it's the whole circle minus this little chunk. So I'm going to do 2 pi or 360 minus the little chunk to get, or minus the angle to get the little chunk that's left. All right, so let's try this. We're supposed to find the reference angle and then sketch it. I actually would do it in the other order. I would sketch it first. So looking at your unit circle, okay, which quadrant is 300 degrees in? So which quadrant is 300 degrees in? Can you guys help me out? Is it in quadrant 1, 2, 3, or 4? So which quadrant is 300 degrees in? All right, nice work. It is in quadrant 4. Okay, so I'm going to draw that. So here's my little XY axis. And I'm going to estimate that it's about right here. Okay. Oh, my goodness, it changed it into a line. Interesting. I think I have this thing highlighted. All right, so this is going to go all the way from here to here. That's my theta. That's 300. Okay. My reference angle is this angle in here. So I need to calculate how big that is. So to get that reference angle, I'm going to do, because it looks like it's going to go almost the whole circle. So on that one, I would have to do 360 minus 300, which would be 60 degrees, which on our unit circle would be the green triangle, right? We would use the green reference triangle, okay? This is a lot to help you if, say, you didn't have the unit circle in front of you, okay? This is another way to approach it, all right? Okay, the first thing I would probably do with number 10, well, we got to figure out where it is. I'm going to try to find something coterminal because I have a hard time figuring out where 135 is. Actually, no, I don't. Let me think about that again. Let's try that again. Let's say if I did this. I know 135 is less than 180 but bigger than 90, right? So that would plot me here. Don't draw that. Okay. But negative 135 would be less than negative 180. So it's going to plop into here somewhere. So that is my theta, which is negative 135. Okay. Oops, I didn't mean to do that. Okay, so that means that my reference angle is this one right in here. To calculate that, I'm just going to do the 180 minus the 135, which was like none of the instructions above, right? I used kind of common sense. I know the straight angle is 180. So 180 minus 135, and my reference angle is going to be 45 degrees. So I'd be using my pink reference triangle on that one. All right. We are going to get rid of 12. We're not messing with anything that doesn't going to be normal. I tried to erase it, but we're going to do that. So cross out 12. Okay. All right. Let's take a look at 11. So 11 isn't one of our standard ones that we have on the unit circle. It doesn't fit a 45, 30, or 60 or a quadrant angle. So this is kind of our true test of what's going on here. So we're going to start by drawing my XY axis. Can you tell me which quadrant would 323 land in? And I'm sorry, it's a poor example because we kind of already did one in that quadrant, but just let me make sure you're still paying attention. Which quadrant? And I know some of you are really getting good at those Roman numerals. Nice. Okay, so we're all in agreement, quadrant 4. It's a sketch, you guys. Sketches are not perfection. Okay, so we're just going to draw it in there. I don't really know where it's exactly at, so I know that this is my theta. Okay, So since we have done one of these before, for my reference angle, what do you think I'm going to do? So put the calculation you think we should do in the chat to figure out how much is left. If I know the whole thing is something, what would the calculation be? All right, you guys are awesome. 360 minus 323. And hopefully, if I can do my arithmetic right, it is 37 degrees. I know we didn't see any examples with radians, but you can do this in radians as well. I want to say that it's in, it might be in the homework that way. So you would just be using pi, okay, or 2 pi, possibly, to do your subtractions with, okay? All right, my goal is to get to 15 today, all right? So that you get some extra time to work and Mrs. Ballard gets some extra time to update grades, okay? All right, so we're going to evaluate the sine, cosine, and tangent without using a calculator. So that means no decimals, okay? So you shouldn't be using a calculator. But they want me to find the sine, the cosine, and the tangent of each one of these. So sine of 4 pi over 3, cosine of 4 pi over 3, and tangent of 4 pi over 3. Okay, who's our best friend in answering these questions? What should I be using? Okay, I'm not going to do it by their method. We're going to practice what we know already. So who's my best friend in trying to do these? What should I use? Oh, good. We've picked up on the clue that's off to the right. Our best friend is the unit circle, okay? And it was funny, I was watching, did you guys know that if you're in an AP class, did you know that starting yesterday, they're doing these AP live review videos from the College Board on YouTube? So I was watching the AB one last night, and the guy was telling me he was a triangle trig guy, and I'm like, I'm a coordinates girl. I love those coordinates, and I know a lot of you guys in here like the coordinates. So yeah, we're going to go back to our coordinates and default there. You just have to find one that works for you, and you can do it the right way every time. Okay. All right, so I'm going to find 4 pi over 3. Let's see, 4 pi over 3 looks like it's right here. My sine is my y value, which looks like negative square root of 3 over 2. My cosine is my x value, so negative 1/2. How do I get the tangent? Can you guys tell me in the chat, how do I get the tangent? If I'm going to use my coordinates, how do I get the tangent? Oh, we're going to divide the sine by the cosine. Good. So I'm going to write negative square root of 3 over 2 divided by negative 1/2. The good news is my double negative goes positive. What can I do right here? So what am I allowed to do? What was the shortcut we learned last week? All right, good. We're going to get to cancel out those 2's. So guess what? It's really just the square root of 3. You could write the over 1 if you wanted, but it's not necessary. So just square root of 3. Okay? All right. On number 14, before I try to find that, I need to figure out what it's coterminal to. So that means I need to add 360 first. So I'm going to add 360 to that. All right, I'm getting to my, so that will give me 150 degrees, which I believe is right here, right? Double check, because I didn't have my degrees unit circle. I only got my radians unit circle. So I'm going to write it as the sine of negative 210 and the cosine of negative 210, because that's the proper way to do this, and the tangent of negative 210. But really where I am looking is the coterminal angle at 150 degrees. All right, can you tell me what is the sine of negative 210? Tell me in the chat, what are we getting? I'll blow it up a little bit if you don't have it in front of you. What is the sine of negative 210? So remember, negative 210 is in quadrant 2. Look very carefully at your coordinates in quadrant 2 and make sure you have your signs correct. All right, I'm seeing a lot of 1/2, which I'm really liking. Remember, sine is positive in that quadrant, okay? Good job, Abby, okay? Make sure when you're looking at unit circle that you've double checked to make sure your signs are correct in there, because you don't want that to be written down wrong and then it messes you up on the test, okay? All right, my cosine is negative square root of 3/2. And then my tangent, you already told me, is going to be my sine 1/2 divided by my cosine negative square root of 3/2. You also told me, hey, you can cancel those 2's. So I've got 1 over negative square root of 3. Uh-oh, what do I have to do now? What's the process called? Although it's possible WebAssign leaves it there. What's the process that we usually go through called? Marianne, that was quick typing and spelled right? Nice. Okay, we're going to rationalize that denominator. Are we doing this in our sleep yet? So we've got square root of 3/3, and then we're going to I'm just going to float the negative in front. Do we have that one memorized yet? Have we done it enough times? I'll give you a minute there, or a couple seconds there, and then we'll do one more, and then we're going to call it good. Okay? All right. Let's take a look at 15. Okay, so 15 is 11 pi over 4, which I don't believe, I have 11 pi over 6, but I only have 7 pi over 4. So if I'm in radians and I need to get something coterminal, so what do I have to add or subtract in radians to find my coterminal? What do I have to add or subtract to get something that's on my unit circle? In degrees, it's 360. What is it in radians? Help me out. What's 1 full revolution around in radians, everybody? There we go. Okay, so 2 pi, but 2 pi in over 4 world means I need to multiply top and bottom by 4, right? Which would make 8 pi over 4. So I'm going to subtract 8 pi over 4, which means I'm really getting, I'm coterminal to 5 pi over 4. So I want to find the sine, but I'm going to use my original in my notation here. Sine of 11 pi over 4, cosine of 11 pi over 4, and tangent of 11 pi over 4. All right, let's go back to my good old unit circle. It's kind of sitting out there. All right, I don't know if I can get it all on one page. All right, so I am going to 5 pi over 4, which I'm seeing is right here. Okay. The sine is the y coordinate, so it'd be negative square root of 2/2. The cosine is the x coordinate, so negative square root of 2/2. The tangent is the sine divided by the cosine, so negative square root of 2/2 divided by negative square root of 2/2. What does that simplify to? Can you tell me that in the chat? What does that simplify to? Nice work, everybody. Good job. Good job. Okay. That, in fact, equals 1. All right. That's it. I'm going to stop there today. That's enough to get you through the homework, okay? Tomorrow, my goal is to finish up whatever we're going to finish up on this. Thursday, Friday, we'll do the last